All right, before the break, we wrote the routine to, sorry, I'll make this a little smaller. Whoa, there we go. We wrote the routine. We were in the CMB statistics selected index change. That's the default event for a combo box. When the user picks something new, this happens. And what we've been doing is going through and saying, okay, if they picked count, then show them the count. If they picked sum, call that method. How do you flowchart that? You don't put the flowchart for calc sum in here. It's its own method. It now has its own flowchart. So now you have more flowcharts to write, right? No, it should be less because we're reusing it. And each flowchart is a little bit smaller. When you call a function, a method, you use this box. It's a box with little sidebars on it. That means another process. This basically says call calc sum. It's not a rectangle, it's a rectangle with sidebars. And it's on the list. It's right there. Okay. It means call another process, a sub-process. And so here I'm calling calc average. And then if I go over here to these other ones, somewhere I have my calcs, here's calc average. It calls calc sum because I don't have the if statement in here. What does calc sum do? Here's calc sum. Start the counter off, go through it, end. Then after the calc sum is done, then calculate the average. So when you're flowcharting these, you use the rectangles with the little sidebars to say I'm calling a sub-process. If you want to know how this is done, go look in calc sub. What it allows maintenance programmers to do is look at this and say, yeah, that makes sense. We figure out the sum, then we divide and go. And if they want to know how I figured out the sum, they can go look it up if they really need the details, or they can say, must be magic. I don't care. It works. Go on. Once I hire Karen to do my calcing of sums and I give her a checklist, because this is her checklist right here. Here's the pseudocode for it. Okay. Here's her checklist. Once I've verified that she knows how to do her job, from then on, I don't even know how she does it. She just does it. I ask her to calculate the sum. She says, I'm done. I go, cool, good job. And that's it. And as a maintenance programmer, if I don't really care how this is done, I don't have to go look, as long as the logic makes sense. So that flowchart pseudocode is all out there already. I wanted to show you how to flowchart a call to another subroutine, to a method. That's a call. In pseudocode, you just put the word call. That's old school programming. You call methods to invoke them to get them started. All right, now we have an average. What's next? What else is on my list? Mins and maxes. Forget what the list is, so I'm just going to run it real quick to find out. Min. Let me ask you something. How would you discover the minimum value in this list? What would you do? If I just went scrolling through here slowly, what would you be doing? What does your brain do? It's looking at each value, maybe not in turn because your brain's better than my computer, but it's looking at each value and say, okay, you're the smallest. Oh no, you're the smallest. Oh no, you're the small. No, you're the smallest. And then we go on and on and on and on and on until we get to the end, and then whoever's the smallest wins, right? We just got to make the computer do that now. Start at the top of the list, go all the way down, and as you're going down, remember who the smallest is. We already have a class level variable called minimum. Okay. We also have a couple of constants up here that I didn't recognize. I should have used those when I was generating my random numbers, right? Better go fix that, because if I don't do it, you won't do it. So right here, this should be min value, constant, and this should be max value, constant. It'll still generate numbers between 0 and 100, but now I can easily change the limits of my numbers. Why did that matter? Yeah, because when I calculate the minimum, it can be handy. So we're going to calculate the minimum. Where is it? Doesn't exist. Or determine, I'm sorry, there's no calculations involved. So in my mind, and this is experienced programmer thinking, if I'm not doing any math, I'm not calculating. I'm determining the minimum. What we have to do is start with something. So when I'm determining the minimum, where do I start? Actually, you know what? Let's do maximum. It's a little easier to think of for most people. I'm figuring out what's the largest number in the list. Where do I start? With the first number. That's what I did. That's a good answer. We can do that. So how do I know what the first number on the list is? Very good. Very good. List numbers dot items. She wants number 1. I think that'll work. Just not. Definitely 0, because that's the first one. But the 0 is not working. So how do I get to the first? That ought to work. What's wrong with that? That's what you get for being in the first class again. List items cannot explicitly convert an object. So this first item is an object, so I would have to parse it as an int. Ugh. Okay, but I know it's an int, right? It has to be. So parse it. Parse, int.parse. The first item on the list. Remember, it's in position 0. You happy now? Still not happy. Well, that's an object. It's not a string. So I can't parse it. So that was a good idea, but it didn't work. I'd have to do a toString on it to get item number 0. What other option do I have? Why don't I just start at the minimum? If I start at 0, isn't there bound to be a number bigger than that? Because that's my minimum value in the list. That's where I'm going to start, and I'll check the first one. Are you bigger than my minimum? Yep. Good. Or maximum. We're on I'm sorry. But min value is correct. We're doing maximums. Are you my maximum? My constant.
Oh, okay.
Right? It's a constant. Good. Now Paul's here to keep an eye on me. I'm having one of those days, Paul. I'm glad you're here. Okay. I set my maximum equal to 0. I'm bound to find something bigger than that. What if I generate, and this could happen, right? 50 numbers, and they're all 0. It's the maximum. It's still good. It can't be any less than that. That's one option. But what if I was generating random numbers between -50 and 50? Then I could still make this -50. There's one other option, just so you know it exists. int.minValue. What? Integer, we're asking the integer class, hey, integer, what's your smallest value, like -2 bazillion? Let's start there. We're bound to find something bigger than -2 bazillion. I think it's 2 billion. Let's see what that comes up with. Just put a breakpoint on it. Right here, go, and we have to determine the maximum. Max. Did I call it? No. The problem with having all these functions, you gotta remember to call them. So I'm gonna go back in here, there's maximum. Oh, that is so annoying. The reason I do that, by the way, why do I keep trying to change my program when it's running? Because I can in Swift. You just go change it and then run it again. Stupid Microsoft, better catch up with that one. Determine the maximum, and then, you know what, while we're at it, go ahead and display it. We're going to need to anyways. And I don't need to format it because it's an integer. So I have to call that function. It's a very common mistake. You write this beautiful function. I write all these steps for Karen. I say, here, actually, it's not Karen anymore, so we're moving on to Tyler. You're Mr. Calculate the maximum. And he goes, thanks, there's a list. Now I know how to do my job. I got to call him. If I never call him, he never does his job. Just because he's sitting here in this position means absolutely nothing, because we can alphabetize and screw them up if we want to. It doesn't matter where they sit. They don't get called until you call them. So now I've called them. Now hopefully this will let me break point. There we go. What's in here? Minus 2 billion and change. So that's a nice small number to start with. It's extreme. I like that one because it always works. Every language has an int.min something. So I use that one. But the recording also now shows you that you could use, as Cian said, the first item on the list. Unfortunately, with list boxes, that's not easy to do. Or I could use the minimum value that I'm generating. That's perfectly acceptable. That always works too. But I have to start at someplace. That's the key. When we were looking through that list, you looked at 74 and said, you're the smallest on the list. Now the next one, next one, next one, until we find it. So now we have to walk through the list. How do we do that? For each. For each item is a string. Boy, I tell you, walking through that list box is getting more and more annoying because there's strings. That's all right. We can parse these. That's not so bad. String. What am I doing? Item. In CMB number or list numbers dot items. Walk through the list. I could have gone up here to calc sum, because isn't that kind of what Karen was doing? For each number in there and then parse. I'm going to steal that real quick. Copy that. So I could have stolen that. I wouldn't have to think quite so hard. And here it said for each number instead of each item. It's just a variable name. You can call it what you want. So I better change this one to number so that it works just like the other one. For each number in numbers. No, items, capital I. Gee whiz. Paul, take over. I'm done. There's my for loop. Shouldn't be so hard. Same as the other for loop. Walk through all the items. What are we going to do when we calculate the minimum? Walk through all the items. Again, you do it a lot. You can use the same loop. What do I want to do here? I want to check to see if the one I'm looking at, number, is bigger I'm going to have to parse it first. That's where the parsing goes. I'm sorry. If the number is bigger than my current maximum, because up here I set the maximum to some minus bazillion. Is the first number on the list bigger than it? Probably. If that's true, it's bigger than the maximum. Okay, I'm going to do something here. I don't want to do this over and over and over again. I'm going to do it once. Now I can say value and leave all this other stuff out. If the value that I'm looking at right now is bigger than the maximum, all I've done is permanently changed this from a string to a number, gave it a new name. If my value is bigger than the maximum, then hey, the maximum is that new value. That's the logic. Let me show it to you again. Okay, my program said start at 2 billion. So, Brian, I'm putting you to work. Your job is to remember the current maximum. Currently it's 2 billion. Got it? Okay. My logic says, look at the next number on the list, 91. Is that bigger than the number you currently have? Yes, it is, because you got minus 2 billion. 91 is bigger than minus 2 billion? Minus 2 billion. Is 91 bigger than minus 2 billion? You say yes. I go, oh, okay. Then Ryan, I want you to remember this current value instead, 91. Take out the minus 2 billion. Now you're remembering 91. I go to the next number. 60. Ryan, is that bigger than the number you're looking at? No. 94. Is that bigger than the number you're looking at? Then the number you're remembering now is 94. And it goes and goes and goes, and these are all no, 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 no. How about a 95? Is that bigger than your number?
Yep.
Yep. New number is 95. 99, is that bigger? Yep. 100, that bigger than the number you're looking at? Yep. I'm not going to find anything bigger than that. Now I could write logic to say, if the number we found is equal to the max, quit. I'm not going to do that. But that's the process. It starts at the top and said, is this bigger than the number we have so far, which is minus 2 billion? Yes. Then remember that one instead. Is this bigger than that number? Yes, then remember that one instead. And we just keep going through every item. In this case, we do go all the way through and find the biggest number. In this case, it's 100. Generate some new numbers. Give me the maximum. Another way we could do it, sort of grab the last one. But we saw how hard it was to grab the first one. It's not any easier to grab the last one. Paul, if you're wondering why, it's because this is an object. And converting that object into a string and then into a number is just not worth my time. And sorting is generally very time consuming. If you have a very large list of numbers, sorting them can take a long time. So if there's another way to find the maximum without having to sort, that's probably a better plan. And that's what we have here. So this little piece of code says go through every number. If it's bigger than the current maximum, that's kind of what that means, the current maximum. If the number you're looking at now is bigger than the current maximum, make it the maximum. Done. What do you think minimum looks like? Pretty much the same. So let's go to the case statement and call that before I forget. Which number? This number? That number. It's my loop variable. Yeah, I changed it because it was, I wanted to make it the same as the other one. And so since I'm going to cheat these two lines of code, I'm copying them. So I'm going to use them again. Selected index change. Now I'm going to determine the minimum. And display it. Got a column. I think it's time for you to stop and watch. I'm worried about lecturing at you all next week. I don't want to do that. For each number in the list. But I need to initialize it. Where do I initialize it? 0, right? What's smaller than 0? Nothing. So when you're looking for the smallest, you have to initialize it to some extremely large number. Either 100, because that's the biggest number that I'm generating, or there is an int min equals int.max number. That's the trick. It's not a trick. I started 2 billion. First number on the list, definitely smaller than that. If I start at 0, nothing's smaller than that. That's a very common mistake. You start at 0, and as long as there's a 0 in the list, it works. But as soon as the smallest number is 5, it still says 0, and you go, there is no 0. That's why I did these backwards. I have to start at the max. Then the logic is very similar. If this value that I'm looking at is less than the minimum instead of greater than the maximum, then it's the new minimum. Cian's suggestion to pick the first number of the list is solid. It works. First time through the list, you compare the number to itself. That's a waste, but so what? Because it's never less than itself. It's never great. What about ties? I'm not asking. I'm just wondering. I don't know. I want to know how many times it appears. I want to know what's the biggest number that's on the list in this case. So that calculates my minimum. Lots of statistics going here. We're almost done. Oops. And if for loop's missing, it's curly bracket. Now let's test it. Pick all kinds of statistics. Give me the count. Give me the sum. Give me the average. Oh, that's lucky. Is that doing, oh, that's not doing its math right, is it? I keep getting zeros. That just can't happen. What am I doing wrong? Pardon me? I need to make one of them a double when I do my average calculation. When I'm calculating my average, I'm working with two integers. That's an integer, so's that. That's better. There's my minimum. I could go through the, let's sort them. Minimum's 5. Maximum's 100. Two more things I want to calculate. First one's the range. The range is what's the difference between the min and the max. Not a problem. Here's calculate the range. Let's go call it real quick before I forget. Calculate the range. And then display it again. And then there's a calculation routine, another method to do that. How do I do that? Well, again, the user could click on this first. In order to calculate the range, I just subtract the min from the max. That's the math, I think. I hope. That's what I've been doing for 10 years, so I hope that's right. Subtract the min from the max, but I got to have them first. So I calculate the min, or determine the min, excuse me. Notice whenever you call a method, you have to put the parentheses there. And I need to determine the maximum. And then the range is simply the min minus the max. Now the min and the max are available. Done. Quick test, sort them. 2 and 97, so the range should be 95. Now I looked and sorted first. Would have gotten the right answer anyways. The final option is all. Really? Now we got to go calculate all these statistics? It's really not that bad. The worst part is displaying them all. Because calculating them all is not that hard. Underneath here, all I have to do is say calc sum, calc average, calc min, calc max, calc range, calc count, right? No. What happens when I calculate the average? Side effect. I get the sum, right? Because in order for average lady here to do her job, she's got to call the calc sum lady. So when I call her, side effect is I also get a sum value. What happens when I calculate the range? Min and max. So really all I have to do here is say calc the average, because that also calcs the sum. And then calc the range, because that also calcs the min and the max. And I'm done. Got everything I need. The count is right there in my list. I don't have to calculate that. There's no method to calculate it. So now all I really have to do is steal these displays. And this is tedious, so aren't you glad you aren't following along? Is there a quicker way? No. Not that I can come up with. If it was Microsoft Word, I could do a collection, but I don't think I can pull that off here. Let's give it a shot. Yeah, I didn't think so. I'm just copying and pasting all those because I want to display the same stuff. I just want to display it all at once. So these two commands calculate everything that I need. And then I just display them. The only thing I still need to figure out is the count, but that comes right from the list box. So now if the user doesn't want individual statistics, I want them all. That's a lot of work. What's the point? It's a looping chapter. What's the point? Well, side points. It is important for you to have seen at least once and have a sample of how to calculate these statistics because they are so common. A sum all the time. Average, mins and maxes. That's not one that's intuitive necessarily. How do you calculate, going through a list of numbers, how do you calculate or determine the min and the max that's in there? So I wanted to show you those. But this is a looping chapter, so the most important stuff here are the loops. There's a for each loop. Walk through every number in the list. It's also about list boxes. Everything in the list is not a number in this case, unfortunately, it's text, and so we have to manipulate it slightly. But the for each loop is what's important. Start at the beginning, go to the end. No counters, no nothing in addition to that. There's also combo boxes here. The validating of a combo box. I believe the assignment tracker said make sure that the course that the user picks is on the list. It's right here. So that's the point. Mostly loops. Lots more examples of loops. Unfortunately, they're all very much the same, aren't they? That's also a point. For loops or for each loops are also very much the same. Some variable in some list. They all look the same. Walk through them. In preparation for Monday, so I don't have to talk any longer than about an hour, I'm going to go back to my notes and remind you of what pre and post test loops look like. We're going to do one example of each next week, and they're short examples. That's interesting. Jump to an empty page. Remember the looping concepts. If we know the exact number of iterations, we know how many times we're going to go through it. There's this many numbers in my list. You use a for loop or a for each loop. Counter control. If you don't know how many times you're going to go through it, and our validation loop is a pretty good example of what we should have done, one of these other ones. Do we have to go through the process at least once? Let's see, we were checking to see if it's the first one. We had to do at least one item on the list to see if it's there. We should have been using yes, at least one iteration, yes, a post-test loop. That's what we should have done. Maybe we still will. Otherwise, it's a pre-test loop because we don't know how many times we're going to do it. So now let's jump down here. Let's just use these. A pre-test loop checks at the top because I might not do the loop at all. This is that classic user screwed up. Did they make a mistake? No. Skip it. Yes, they screwed it up. Then yell at them and erase their answer and do whatever else you have to do and then get their new answer. Did they screw that one up? Yes, do it again and again and again and again until they get it right. But if they get it right the first time, you can bypass the loop. That's a pre-test loop. It tests at the top. Before it even executes the loop, it executes its test. If the test is false, it skips it right away. A post-test loop, on the other hand, must go through the process once. Compare what the user typed to the first item on the list. Does it match? No. Then go to the next item on the list, but you got to go through the process once, and as soon as the answer is yes, it matches, you drop out. And you don't keep processing the loop like our for each loop wanted to. So two other kinds of loops. They really come into play today if you can't figure out how to do it with a for each loop. Where they really come in handy, this one particular, is go read my file of overdue accounts. And I want a list of all the it's in a file someplace. We're going to do this next semester. Read from a text file. Read them in. How many are in there? I don't know. Could be none. But if there are some in there, as long as we haven't hit the end of the file, and that's actually a programming term, end of file. If we haven't hit the end of file, read the next one, process it, do whatever we got to do to it, print it. We hit the end of file yet? Nope. Keep going, 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 end of file, yes. But we don't know how many there are. Classic loop. And we can't use a for each loop for that because the file exists, but the list doesn't exist in our program, it's someplace else. So there are still uses for pre-test loops and post-test loops. They're just not as common as they used to be. On Monday, I'm going to write two more little mini programs. The first one is called my progressive sale program. I've always tried to come up with good examples for these that were lame, but one day, all of the ones I had before were lame. One day, I was at Pacelli during their, what's it called? Their big festival in the fall, Pacelli Panacea. It was a Panacea, and they had a progressive sale. A progressive sale means it starts at full price, and then every 5 minutes, every 10 minutes, every hour, every day, not Pacelli, but every 10 minutes, it would go down by 10%. 10% of the price. So it went from $100 to $90, from $90 to $81, $81 to 70 some dollars and 90 cents. Until finally somebody couldn't stand it anymore and they bought it before anybody else did. It's called a progressive sale. However, the person who was running the progressive sale told me, I said, when do you quit? Can I get it for a penny? She said, oh no, we stop at $1, $5, whatever. How many times does it take to get from $100 down to $5? There's probably some genius mathematical formula to figure that out, but I don't know what it is. So we're going to use a loop, a pretest loop, to go through that process. Because what if the price of the item is already $1? Then skip it. Don't even mark it down anymore. But we'll make a list. And write a little app so that next time you go to Panacea and there's a progressive sale, you can go, I got to hang on to this for about 6 hours because that's when the price is where I want it. And you can plan ahead and hope nobody buys it before you do. The other program we're going to write is called column headers. In the number systems binary that you learned a little bit about in networking fundamentals, our number systems, the column headings are ones, tens, hundreds, thousands, millions. 10,000 and 100,000s in between there, sorry. Okay. In the binary number systems, the column headings are different. It's ones, twos, fours, eights, 16s, 32s. And what I want is an app that tells me what each one of those column headings is, up to 1,000,000. How many column headings would it take to get to 1,000,000? And then if for some reason I have a base 8 number system, how many column headings would it take? And what are the column headings? So we're going to write a program to do that. I want to get to 1,000,000, but again, mathematically, I don't have the smarts to figure out if I'm jumping by 8 every time. How long does it take to get to 1,000,000? I don't know. So we're going to do a post-test loop for that. Each of those programs is about 6 lines long, because the loop does all the work. So that's what we're going to do on Monday. I promise no more than an hour. Then we're done. No more lectures in programming logic beginning. Those of you that miss me, it won't be long. We'll be starting over again with programming logic beginning part 2, where the real fun starts. Programming logic intermediate. It just picks up where we left off, that's the point. It's like we just take a little break and then we get back at it again.
Intermediately.
Intermediately. Yes.
That's fun, maybe.